Today we will discuss about Jahn-Teller distortion. So what is Jahn-Teller distortion? A nonlinear molecule in an electronically degenerate state will undergo some sort of distortion that will lower the symmetry of the molecule, remove the degeneracy, and thereby lower the energy of the system. Here I am going to provide a chart . Configuration for which Jahn-Teller distortion are expected in ml6 complexes. Ground state term now. If the configuration is D1, definitely the ground state will be 2T2G. Here it has been observed that this particular configuration is Jahn-Teller active. For D2, the ground state term is 3T1G. Here also this is Jahn-Teller active. For D3, it is 4A2G. In this case, since the ground term is non-degenerate, this particular configuration is Jahn-Teller inactive. For D4, the ground term is 5Eg for high spin and 3T1G for low spin. Here both the high spin and low spin configuration is Jahn-Teller active. For D5, there are also two possibilities: 6A1G for high spin and 2T2G for low spin. This one is non-degenerate term, therefore Jahn-Teller inactive, and this one is Jahn-Teller active. For D6 also there are two types of configuration, high spin and low spin. 1A 1G for low spin and 5T2G for high spin. So this one 5T2G is definitely Jahn-Teller active, but this one is inactive. D7 4 T1G for high spin and 2 EG for low spin. Here also both are Jahn-Teller active. For D8 system, it is the ground state term is 3A2G. There is no other possibilities here, and this one is Jahn-Teller inactive since the ground term is non-degenerate. For D9 system, there is only one possibility, 5 EG, and this one is Jahn-Teller active. Now we will discuss about possible qualitative energy level diagram. Suppose this one is an octahedral configuration. So definitely from the crystal field theory we know that the 5d orbitals will be splitted in EG level and T2G. Here the two orbitals are dx square minus y square and dz square, and here dxy, dyz and dzx. Now if the orbitals along, we can say the ligands along the z axis comes a little bit closer to the central metal atom, then what should be the situation? This is known as Z in Jahn-Teller distortion. In this situation, the energy level diagram will be like this. The dz square orbital will be rest in energy, and the energy of dx square minus y square orbital will be slightly lowered. Why? Since the ligand along the z axis comes a little bit closer towards the central metal atom, therefore the repulsive interaction between the central metal atoms dz square orbitals and the ligand will increase, therefore the energy of this particular orbital will get increased. Now if we designate the energy difference by delta 1, then this energy is half delta 1 and this energy is also half delta 1. For T2G orbital, what should happen? The splitting of the energy level will be like this. Though here it looks like the energy difference between these two levels are quite same, but actually delta 2 is less than delta 1. Okay, delta 2 is less than delta 1. Similar situation happens if we elongate the metal ligand distance along the z-axis, then it is known as z-out Jahn-Teller distortion. In this situation, what should be the energy level diagram? So this is for Z out Jahn-Teller distortion, this is for Z in Jahn-Teller distortion, and this distance is delta of diagram. Okay.